Hello, I'm Andrew Colby, and I'm going to speak with you today a little bit about VIA AIOps, what it is, and how we deliver our value. VIA AIOps is supporting complex operational environments. These environments are getting more and more complex every day. No one that we talk to is getting a budget increase. In fact, most organizations are needing to do more with less. And this part of the organization is often a place that many people enter the organization. It's a challenging place to keep institutional knowledge. And as the environment grows more and more complex, many skilled people feel that they're doing menial and repetitive work in order to gain the insights needed by operations. What the operations teams are doing that are using legacy tools is looking at their services, their applications from a network and application perspective. We refer to this as siloed monitoring, where you're looking within your specialized silo where you have your expertise. The challenge with this is that the services now are becoming more and more disaggregated and virtualized and depend upon many components in order to be able to successfully be delivered and successfully consumed by the user. So seeing an event that takes place in one part of the service delivery chain, if it's an application, physical infrastructure, virtualized infrastructure, network, does not give the operational engineer insight into what the real impact is on the service, on the subscriber, and often takes a considerable amount of triage when there's a service impact that's identified. This can often generate multiple incidents within the operations team. These are often uncorrelated because they're just symptoms of an underlying problem. And they're typically only brought together through manual actions by a team of people. This results in some people working on symptoms and some people working on the true root issue. The net result is more time, more expense, longer resolution, and not the desired result. In addition, some of the really important constituents, including the change management team and the customer support customer operations, are not really first-class participants in this process. So the net of this is that the operations team, they need to adapt. They need to update their tools, methodologies, and capabilities for this modern environment. It's not possible to succeed at scale with human-based monitoring and human-generated rules. This has been attempted in subsegments, and the example I'll bring here is in the security world for firewall rules, where human-generated rules are created every day in a large organization. A new set of rules and policies is added to every firewall, and after a short amount of time, no one can really tell what's going on, what the policies are that are enforced in that device, and troubleshooting is very difficult. So really, with the complex service environment, augmented intelligence, automation, and algorithms are going to be required to succeed at scale. What this will do is allow observability across the domains, not just within the domain, will allow integration of the impact of change management with the rest of operations, will accelerate the identification of faults, impact, and root issue. And it allows for an incremental way for this technology to be introduced into the environment, into the operational environment. We refer to this as incremental transformation, where the AI ops capabilities can augment the existing institutional knowledge with algorithms, machine learning, and artificial intelligence. And it can leverage and multiply the value of existing tools and measures that are in place while improving workflow and efficiency. So what does this look like? Well, it looks like getting raw data direct from all of these sources, pulling it together in real time, enriching it, correlating it, and incorporating additional data sources such as customer experience measures and change management to produce valuable insights and In VIA, we refer to these as smart tickets that bring together the root cause, key symptoms, and impact on the service that can subsequently be fed to automation, incident management, ITSM systems, as well as identifying and delivered to the correct fix agent. Here's an example system that's ingesting tens of data sources representing hundreds of different data types across a nationwide network. This is a summary view in what we call our Incident Action Center that gives at a glance information about what the issues are, what the impacted parts of the network are, what the impacted services are, and who's likely affected from a subscriber or device and device perspective. So what we see here just at a glance is the network itself has identified that there's issues. In this case, listed under probable root cause is a link down. Now, this service provider gets hundreds, thousands of link down events every day. Because they have the potential to impact service, they generally have to be investigated unless they self-clear. And the question is, which of these link downs are service impacting, which of them are not, which might just be related to an existing maintenance event, or might be on a backup or redundant path and not directly impact end user service. By bringing together not only link state information, but also the service level information, so we can see services over the tops of the link. So here we can see and show BGP state as well as protocol state over the link, and identify not only which link is down, but VIA has the ability to learn the dynamic topology of the network and identify what's on the other end of the link, not just from a physical infrastructure, but from a logical and service infrastructure that is displayed here, that's learned from the network and messaging itself. In addition, identifying the subscriber impact. In this case, this is a service provider that serves retail and business subscribers. And here, there's actually subscribers that have called into customer care and reported a problem at the same time or shortly after the event that's been reported taking place in the network. We can see that these events are actually ingested and scored by VIA. They accelerate in severity until they reach a high severity. And interestingly, here we can see that the event is shorter. The customer impact, the customer experience event is shorter than the network event. And that's because through this automation, the service provider is able to identify the impacted subscribers, set up deflections in the IVR, and do proactive notification of the subscriber for the service impact. So this ends the care events, which prevents the service provider from incurring unnecessary additional cost for call center staffing and the inevitable technician dispatch that comes as fallout from high volumes of customer calls. Now, all of this is actually done automatically. This can be seen here, where the system not only ingests the data and correlates the events, but actually scores and measures subscriber impact and reports this changing over time. So this is important and can be fed to care operations as well as to the ticketing and IT service management systems in order to gauge and understand at a very granular detail the impact of these events. I want to show you another example from the change management side, from the change management perspective, of another way to look at this kind of information. Now, this same information, this system provides the same kind of view from an incident action center and summary view, but also we have access and can display very granular detail as well. So in this particular case, we can identify change management tickets that are scheduled maintenance, and we can actually identify the subscribers that are impacted by the change and what their reaction is, what their behavior is when we monitor that population of subscribers after the change. Now, this particular VIA customer is very focused on the impact on the technician dispatch to the house. Trouble calls is what they call it. And when we look into the trouble calls, we can see that for every one of these subscriber groups, this is about 41,000 subscribers, we have a normal behavior for them, their typical behavior in the past, that's a baseline, and we can track their behavior now for a few days after the change takes place. And we can see visually here, and it was alerted in the Incident Action Center, that the subscriber behavior is materially changed. Now here we're talking about 6, 8, 10 calls in an hour. We're not talking about hundreds of calls. And this is in a service provider with millions of subscribers. This level of granular detail of subscriber behavior and subscriber impact is easily visible. Not only can we identify when there's an impact, but we can get to a level of detail of what the problem is or what the subscriber is experiencing and what they're reporting. So here we can very easily see which services are impacted, high-speed data, video service. We can get other information like where the subscriber is or what markets they're in, what equipment they have, whether it's UE or in this case, HFC equipment. And from here, when we want to get to the granular detail, we can get all the way down to individual subscribers, individual account numbers, so that this information can be fed to care operations for both impacted and potentially impacted subscribers. Again, this is used by our customers for both problem identification and customer communication. The customer communication can be proactive notification of problems impacting their service, as well as call deflection. So when the subscribers reach out to the service provider, if they want to report a problem, the service provider can auto acknowledge it and prevent unnecessary technician visits and unnecessary service calls from being scheduled.